All right, in this particular problem on federal income tax returns, self-employed people can depreciate the value of business equipment. Suppose a computer valued at $2,765 depreciates at a rate of 30% per year. Well, that's decay, you know. Okay, estimate the number of years it will take for the computer's value to be $350 or less. So you're going to start off with the general equation, exponential equation, f of x equals a times b to the x. So that's where we start. F of x equals a times b to the x. Now understand, this is your beginning amount. Okay? The b, so a is the beginning amount. B is going to be either 1 plus the rate if it's growth, or in our case it's going to be 1 minus the rate because we're depreciating or decaying. Okay, so this is depreciation or decay. Okay, or decay. All right, and the x in this case is time. So if we're looking at this particular case, our function, our beginning value when they first buy it is $2,765. Okay, now we are depreciating at a rate of 30% per year. So we're going to go 1 minus, actually that's 100% minus 30% to the t. All right, these are both percents. All right, so 100% minus 30% is 70%, or in decimal form, 0.70. So here we go, 2,765 times 0.7 raised to the t power. Okay, now they're asking you to estimate the number of years it will take for the computer to be less than $350. So we're going to go right at 350. So we're going to set the value of the function, which is f of x, we're going to set that to $350 equals 2,765 times 0.70 to the t. All right. Now, if we were to do this by graphing, which I'm fine if you do it this way, we're going to set the left side of the equation equal to y1, the right side of the equation equal to y2. So we go to our graphing calculator over here, and we set this up. So we're going to enter 350 under y1. We're going to enter 2,765 times 0.7 raised to the x power. We're going to go to our window. Our x min is going to be 0. And I'm thinking that most vehicles will probably, or most computers are going to probably depreciate over a 10-year period. Let's double that. Let's triple that. Let's go 30. Okay? So we'll go with a scale or increment of 2. Okay? Now, the fact that this is decaying, that means that the largest value that for this computer is 2,765. Okay? From the beginning, it's going to go down. So the value at max is going to be 2,765. So if we set our y, and it's not going to go below 0. So we go y min is 0. Y max, let's just make it an even 3,000 to make it easy. And we'll have increments or a scale of 500. Okay? So now we have our window properly aligned. Let's graph it. You can see right here, this is where the points intersect. So from, if this is time, then from this point forward in time, then that's going to be less than 350. So what we want to do is find this point of intersection. The way to do this on the graphing calculator, you go second trace, and down to option number 5, intersect. It asks you, is that your first curve? And you go, sure. Is that your second curve? Hit enter again. Do you want to guess? Heck no. Enter again. Boom. And you will see that the x value, which is the value for years, at 5.79 years, it will hit a value of $350. So we can say 5.79 after 5.79 years, 5.79 years, computer will be less than 350. Okay. Now we could have done this also by performing, doing this algebraically. So if I were to take this equation right here and try and solve this, well, see if I can move it. Actually, what I want is to take this equation right here and solve that. So hold on just a second. Let's go to a new page and see if I can bring that up. Okay, so here we go. I'm going to erase the top, erase the bottom, bring this up. Okay, so if I were to solve this algebraically, what I would do is I would divide both sides by 2,765. Okay? All right, and on the calculator, doing that division, 350 divided by 2765, I get a decimal of about approximately 127. So approximately 1.127 is equal to 0.7 to the t power. So when the exponent, or when the variable is in the exponent position, this would be a proper time to take the log of both sides. So I'm going to go log 0.127 equals log 0.7 to the t power. Using the power property, then I'm going to move the t from the exponent position into a factor or multiplier position. So I'm going t times log 0.7 is equal to log 0.127. And then to solve for t, all I have to do is divide both sides by log 0.7. Log 0.7. Log 0.7. These will cancel, and I'm left with t. And then performing that division of logs on my calculator, I would go log 0.127 divided by log 0.7, and I get approximately 5.78. So t is approximately 5.78 years. And you can see by the fact that we rounded that our answer is slightly different, but not a whole lot. If you look at this and you look at the previous page, 5.79, 5.78, pretty dang close.